one of the things that is probably more underestimated than literally anything else when it comes to amateur radio is the relationship that we have as amateur radio operators with the sun and with the space weather environment. And I don't think a lot of people really get it. And so I've been wanting to do this for a while because this is something that's been an interest of mine for a long time, long before amateur radio. Back when I was a teenager, I used to read about space weather, and it's just been an absolute interest of mine. And so I'm going to run through this. It's probably going to be a long one. If you guys have to duck out, I won't hold it against you. But I want to make sure that we cover all the bases on this, because especially if you're on HF, this affects everything you do. Every single thing you do is affected by this. And so it's so important that we as amateur radio operators, that we understand the relationship that we have with the sun. And if I get to somewhere that you know more than me, please step in, because you probably do. Okay. I'm going to run through this. I've got some neat slides of a bunch of different stuff in here. And so to start with, what we're basically going to be discussing tonight is the solar basics. This is something that's lost on some people. They're not sure what is the difference between a coronal mass ejection and a solar flare. Well, tonight you're going to find out. Sunspots, coronal mass ejections, our geomagnetic field, effects on the amateur radio transmissions, the Carrington event, which I'm going to go into a little bit of detail with the Carrington event, because this is a one in 500 year event that we might see repeat itself. Solar and space weather web resources, and we'll get to that towards the end. You know, when we're talking about space weather and we're talking about the relationship that we have in this solar system with our sun, it's amazing. Our sun, it provides everything to us. And it also is lethal to us. It's absolutely lethal. When it goes off, it's like a bomb. And the only thing that protects us is something right out of Star Trek. It's our deflector shield. It's this amazing thing that's created by the weight of our iron core. It's actually created by the planet. It's a science that we don't even fully understand, gravity and how it works, and how this gravity well goes around our planet and protects us from everything. It repels things, it repels energy, and it converts things into forms that are not destructive to us. Our magnetic field is absolutely one of the most amazing things in nature, and it's taken for granted. Our sun is potentially lethal to everybody in the solar system that's not protected by a deflector shield. And that's basically what our planet looks like out there every day, with our shields up at red alert, because the sun is constantly fighting us, trying to kill us, and it can't get to us because of our deflector shield. And I just think that's some really cool stuff. Basically, when we're talking about, whoops, let me go back here. I'm still hearing myself back somewhere, and I don't know where that is. Hold on. I think it might be over here. No, it can't be there. Oh, I know where it is. Hold on. Give me just a second, folks. Hold on. I'm sorry. I have to know this out. It's absolutely killing me. There we go. All right. 50 clicks later. There we go. All right. So anyway, basically there's different kinds of storms that we get from our sun. The first one is a solar radiation storm. Warnings are possible, but they're only going to come in minutes. Did I skip a slide here? I did. Okay. I'm sorry. Solar flares. These are the first ones. When these happen, when solar flares happen, it's a sudden burst of energy from the sun. There's no advanced warning. These come in at the speed of light, which, you know, is like 4 minutes. It's really not a lot of time. The effects usually last tens of minutes. They're high frequency, and they generally impact the sunlit side of the earth. If it's significant enough, it can affect frequencies as high as VHF and UHF. this is the first indication of something bigger, which the next one would be a solar radiation storm. Warnings are possible on these, and I'm going to show you why the time scale is so important on this stuff in just a minute. I've got a great graphic for that. When we're talking about a radiation storm, warnings are possible because we're talking about minutes now, maybe up to an hour or two. Effects can persist for several days, and it's effective to our satellites and our people that we have up in orbit, and it also causes HF blackouts in polar regions, but not as much effective on us. But then we have the geomagnetic storm. This is when this energy from whatever form reaches the planet. Once that energy reaches the planet, now this slower energy that comes later creates geomagnetic storms. It comes and it arrives in a day or two. We actually know this is coming. There's actually predictive maps that we can use to kind of see when we're getting this slower moving energy that creates these storms. They can last for a day or two. Power grids and operation stability can be a problem. And they also create maximum usable frequency depression, meaning that your MUFR, your maximum usable frequency, will drop during one of these events. Global navigation satellite systems are a problem. And of course, they create things that are on my bucket list. The aurora, I've never seen one. You know, it's amazing to see how few of us have seen the aurora borealis. And it is one of this planet's amazing beauties, and we'll get to that here in just a few minutes. But aurora is sometimes referred to as the polar lights. You know, we always hear aurora borealis. Do you know what that means? Well, their polar lights are called aurora polaris. The northern lights are aurora borealis, and the southern lights are aurora australis. And so depending on where you're seeing them is what kind of lights they are. So I just thought that was kind of interesting. Aurora, although it should be aurorae, most people say auroras, and it's accepted, is a natural light display in the Earth's sky, predominantly seen in the higher latitude regions. Auroras are a result of a disturbance in the magnetosphere caused by solar wind. These disturbances alter the trajectories of charged particles in the magnetosphere plasma. These particles, mainly electrons and protons, precipitate into the upper atmosphere, resulting in the emission of light. And man, I'll tell you what, the varying patterns and colors of these lights is absolutely amazing. Like I said, probably one of the most beautiful things in nature when you really go look at it. This video here is sped up a number of times. They don't actually look this fast. Look how fast the cars are going down the highway. But if you've never taken the time to just look at the beauty in an aurora, it is absolutely amazing. And when you think about what's going on up there, that's our deflector shield literally absorbing and reflecting deadly amounts of energy every second. And it does it in such a beautiful way. And you know, it's funny because when you watch Star Trek, you always see the phaser hit the ship, but it hits the shield around the ship. And you always see the shield going, brrr, and you can see the shield struggling against the phaser beam. That's what the aurora is, literally, our shields struggling against the phaser beam. That's what it is. And I just absolutely think auroras are some of the coolest things in the world. So there you go. There's my little trip through nostalgia there. I just absolutely love auroras. Coronal mass ejections, probably the biggest threat to man, bigger than nuclear war, bigger than the gray aliens, which I think the grays are probably most interested in us, but that's for another night. But bigger threat than anything in the entire world. You're more likely to get killed by a coronal mass ejection than any other kind of huge disaster. And that's because this hurls such an amazing amount of energy into space. And then if our planet runs through that energy, it can be a real mess for us. And basically, these originate from active regions. You'll have magnetic fields, and you'll have plasma riding over the top of magnetic fields. And next thing you know, there's a collapse. Things fall in, things splash out. It's pretty simple when you look at it. It's some amazing stuff. In the solar maximum, the sun produces about 3 CMAs a day. CMEs a day. Think about that. 3 coronal mass ejections a day during the peak of the peak of the 11-year cycle. In the slow part of it, in the minimum, they only get one about every 5 days. So you can see there's a drastic difference between the top of the cycle and the bottom of the cycle. So just amazing there. And basically, a coronal mass ejection is when a large amount of the stellar matter, the star material, the plasma, whatever you want to call it, that hot stuff, splashes out. And when it does, it's going to destroy anything in its wake, unless, of course, we have our shields up. It's going to go right by that first planet, no problem. It's going to go right by the second one. They're not really affected that much. It's a rock, no big deal. But by the time it gets to us, and we're talking a day, day and a half later, you know, they all travel at different speeds. And one of the predictive things we have to do with these things is how fast it's traveling towards us. Okay. By the time it gets to our planet, we're the first one that actually has a pretty good sized deflector shield. And we put up quite a fight. But here it comes. Anyway, our planet has this magnificent electromagnetic field that actually, when these waves of energy come in, they actually take that energy and move it around the planet. And by doing that, a lot of it actually comes into the poles. That's why that's where the aurora are, the aurorae, if you will, are most predominant, is in the poles, because that's where the energy. Then when it backlashes, that comes back and that gives you your night side auroras, which is really cool. And so there you go. There's your auroras caused by all that energy that had to be reflected by our deflector shield. So I just think that's absolutely amazing. And maybe I'm just simple. Coronal holes. One last thing on this, and we're moving on. Coronal holes. This is something that when these happen, they can last for several rotations around the sun. And they happen during minimum, they'd happen during maximum, and they do spew out a lot of energy into space, but they're nothing on the scale of the other things we've talked about tonight. Do these affect radio waves and our ability to transmit? Absolutely. You can get a nice wind stream coming from a big, huge coronal hole like this one that's shown here, and it can be geoeffective here and attenuate our geomagnetic field to such a point that it really affects stuff here. So yeah, absolutely. Even though they're not big events, you know, they're tropical storms to the other hurricanes, but it is what it is. Now, when will it arrive? This is the big thing. This is what people don't understand. Well, they said, well, there was a flash on the sun and it blocked out the radio transmissions over the Pacific for 8 minutes. But then they said it's going to cause auroras 3 days from now. Well, how does that work? Well, here it is. When something happens on the sun and it puts out a bunch of X-rays, those arrive at the speed of light. Okay. So we're talking minutes, 4 minutes, give or take. I don't know the exact measurement right now. So this comes on very fast and then it dissipates out. Okay. Radio waves, again, coming in just about at the speed of light. And they're going to come in relatively fast, and they're going to, radio blackouts do take a little bit of time. They're going to dissipate a lot slower than the light stuff did. Then you got your energetic particles. They end up arriving an hour later. They're not traveling quite as fast. When that arrives, they can also be geoeffective as well. But the solar plasma is the one that actually creates the biggest solar storms. And notice it's traveling much slower than the speed of light. It can be traveling very slow, actually, and take 2 days to arrive. Other times it can arrive in less than one full solar day. So it all just depends on how, when we look at it, you know, what we've got coming in, how fast it's going to arrive. And that explains why a single event can have actually 3 or 4 different times of arrival for the different types of energy that's coming in at different speeds. Why know about space weather? Our sun has an enormous effect on not only our climate, but the upper atmosphere that surrounds us and protects us. Knowing about space weather and the layers of the atmosphere help us to understand radio propagation and radio blackouts. You know, I actually witnessed my first radio blackout on my FT8 waterfall. I was on 20 meters. I had a full waterfall. I've split my audio into a second computer where I have a big full screen waterfall so I can see like the last 20 minutes. And I'm watching this thing, and all of a sudden, within about 3 minutes, it was gone, to the point that I'm climbing my tower because I thought my wire must have cut loose up there. I check everything. I can't find anything wrong. I'm figuring, okay, something's grounding out my wire. I can't find anything wrong. I switch over to my ICOM thinking something's wrong with my FT100. Same waterfall. I'm like, what the hell's going on? And sure enough, later on, I find out it was a radio blackout that was caused by a solar flare. And so sure enough, I actually got to witness my first one. I wish I was recording the screen so I could show it to you tonight. But let's just say it's the waterfall for a very active 20-meter FT8 went completely blank for about 7 or 8 minutes. And then over the course of about 4 additional minutes, it was back at full strength, and I'm talking all over the place again. Wow. What a cool thing. I mean, it literally affected my entire ability to communicate. Now, of course, it was not that strong, so it didn't affect the upper bands, VHF, UHF. But man, it had a hell of an effect on 14 megahertz. So I thought that was really interesting. When you're on HF, you want to, obviously it's important, especially if you're doing the low power stuff. The lower power you want to run, the better you have to have, the better environment, the better antenna, the better strategy, being on the right frequency at the right times. And we're going to go into some of that later on too. What is the ionosphere? It's layers of the Earth's atmosphere that range from 50 miles to 300 miles high. It's an area of charged plasma consisting of ions and electrons that carry current. It would be an electrically neutral if it wasn't for the UV radiation from the sun. So once again, we would get zero propagation from our ionosphere. Our HF radios would be useless if it wasn't for the effects of our sun. The more radiation that impacts it, the more reflective it becomes to a certain range of electromagnetic energy. In other words, frequencies, a certain frequency. Layers of the ionosphere. This is really cool. This is something that I didn't really realize till I was studying for this. These things are like mirrors, these layers in the atmosphere. They're like mirrors, but they're like the mirrors that you see in a fun house. They kind of reflect different ways. They reflect a lot over here and a little over there and not really right over here. And so you got to kind of look at it that way when you're looking at this. The neat thing is the left diagram is daytime, the right is night. And you can see there the sporadic E is the dark blue. And that of course, the sporadic E is its own phenomenon that doesn't have as much to do with the sun. It has a lot to do with movement of air, and it's not totally understood. And we'll get into that later. But you could see during the day, as it comes down through the layers, it creates reflectivity surfaces that we are able to then bounce our radio waves off of. At night, the two F layers combine into one big F layer at night. And then, of course, sporadic E can continue on into the evening. I've seen sporadic E run till midnight. So it doesn't necessarily mean it's going to shut off just because the sun goes down. I've seen 20 running later than normal lately, and I've seen 10 running later than normal lately too. So I think it's just something going on right now. Everything seems to like run later in the evening. Could just be more people awake. I don't know. Variations in the ionosphere. You know, there's so many things that greatly affect our transmissions of our radios that we don't realize. Number one, day, night is where you're calling in a day and your night, or vice versa. You know, that makes a difference. Seasonal, hot temperatures in the summer tend to energize the atmosphere and warm up the layers, creating static and pushing the layers up to higher altitudes which actually give you longer jumps. Excuse me, allergy. Your geographical, the location of the landmass and height, sea level will greatly affect propagation, both positively and negatively. I always thought it'd be cool. I'm gonna go set up my rig. Once I get my portable rig ready, and I'm all set to go operate, I'm gonna go up to a place called Buck Bald in Tennessee. It's the top of a mountain that's completely bald, and it's like a park up there, but it's not advertised, so there's hardly anybody up there. And I can go up there and set up antennas and wires, and it's literally almost it's right at 6,000 feet. I want to go there and try it from there, and then I want to go out to an island somewhere and try it from there. I always thought that what a great place would be. So that just your geographical location has a lot to do with how your radio propagates both near and far. Cyclic, because of the effects of sunspot cycle, propagation will vary every 11 years. And of course, as you guys know, last year was kind of the bottom of that, and we're starting to work our way up the good side now. Everybody tells me, you picked a good time to get in amateur radio. You got 5 years to study before it gets really good. Propagation prediction. Everybody sees this thing, right? You see this on every website, right? But yet none of us really want to admit to each other that we don't exactly know what all this crap means on this thing, right? I literally had to go through it myself to make sure, because even though this is kind of my thing, there's a lot of stuff on here. And so I'm going to point out a few of the important ones, what we need to know, and kind of give you some basic ideas. I want you to know the first thing about this thing. This does not tell you what's going on at your house, in your state, or even your country. Most of this information, some comes from Boulder, some comes from other stations around the country. A lot of it comes from Europe. Okay, so when you look at this thing, you can't go, oh, crap, the band's closed, I'm going to bed. Don't do that, man. I'll tell you, when it says all the bands are closed, I go turn the radio on because something's going on. And I'll find a good band. That's when the atmosphere is doing something crazy, and that's when you really want to get in there. So it only gives you an average of what's going on, and the average is sometimes based on multiple sites, but it's not your site. So don't ever get too discouraged by these numbers. But when something's going good or going bad, pay attention to what these numbers say at that time so you can compare it next time. Solar flux index, one of the more important ones that I think is important here. And I don't know if I can, I don't see it. Well, I think, can you guys, I don't know if you, can you see my mouse? Yeah, you can see my mouse. It's good enough. They got like a red dot thing on here. That's pretty cool. But okay, anyway, over here, the solar flux index is this top number right here. First thing you want to do when you look at this on a website is look at the top and make sure that you're looking at a new one. Sometimes they don't update right, and you want to hit Shift F8 or Shift and hit refresh, or Control and hit refresh, depending on your browser. Make sure you got the fresh copy. A lot of times you'll look, it'll serve you the one from yesterday. So make sure you got the one from now. It should be no more than 6 hours old. And remember, the times are Zulu or Greenwich Mean Time or standard time, whatever you want to call it, international time. Everywhere I work, they called it something different. Solar flux index. If it is greater than 90, that's heyday time. I've yet to see it greater than 90 since I've been doing this on HF. We got close. We got up to 87 one day, and it was really cool because everything was open. It was running good. So you want to watch that solar flux index. When it gets down in the 60s and 70s, 70s and low 80s is going to give you more of a normal type day. 60s, I've seen it where a lot of it's kind of shut off. So, you're looking for that to be high. You want that to be 90 or higher. Sunspot numbers. Well, that just tells you there's a bunch of stuff going on. It doesn't really give you anything specific, but if you see that sunspot number is at 2 or 3, that's pretty cool. And the muff is that's not a dirty word from the 70s. The muff is the maximum usable frequency, and it varies based on location. Now, looking at this thing, you can see there's your solar flux index and your sunspot number right there on the top, number of sunspots. Okay. The next thing you really look at, the rest of this stuff's cool. And if you guys want to go in and learn what each of those mean, they're great. I'm not going to play Bill Nye the Science Guy and try to explain each of those to you. So I will tell you that when I get down to the HF area here, the HF conditions, I look at that. I don't use that to decide whether I'm going to go on the air or not, but I like to use it to let me know something's going on. If I look at these and they say poor, 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 all of them are poor, something weird's going on. And I usually can find somewhere where I can find a niche, because remember, when all the bands are closed and nothing's going on, everybody else is out there looking for a hole too that's open. So go out and look. There's something open somewhere. It's never, I could be wrong. And some of these guys, Robert or John or somebody that's been here a long time, can tell me if I'm wrong on this, but I don't know if there's ever a time where every single thing is just completely out, unless it's some kind of radio blackout. So don't ever let this discourage you from trying to go see what's on the air. Down here under these, I want you to notice it says ESEU. That's in Europe. So these are great. You can look at this and you can see what's going on over in Europe. And you just got to remember, when you see what's going on in Europe, they're 4 or 5 hours ahead of us. And so what's going on there may not be what's going on here, or what's going to go on here 4 hours from now, just because we're going to be where they're at 4 hours from now. The only one that's actually in North America is the 2-meter one right here. So that's the only one that's even in our neighborhood. So I just wanted to bring that to you guys' attention. I see people looking at this a lot and going, oh, look, oh my God. Oh, 4 meters, 6 meters is open. 6 meters is open. No, that's in Europe. And if you look a lot of times on the PSK Reporter, you'll see that Europe is open a lot on 6 meters, more than we are, I think. So it's interesting how that works. And then down here, your geomagnetic field, I like to look at that. I mean, that it'll be quiet, unsettled, and it could say storm. It'll say in red letters, storm. There's different things that go in there, and you can look at that as an indicator of something going on. If it says quiet, obviously, then that's an indicator that there's probably not a lot going on. Signal noise, that is an average signal noise amongst a bunch of different stations around the world. Does it mean anything to you? Again, you have to judge that for yourself, because it's not your receiving station that's receiving this stuff. And the muff, same way. That a lot of times is for Boulder, Colorado, I think, is our closest muff station, if you will. And then of course the current solar image, so you can see what's going on. But a lot of times with these things, people don't understand what all that stuff means. So the main thing is look at that solar flux index, and you're wanting 90 or better, means it's going to be amazing. All right, 11-year sunspot cycle. I'm not going to spend a lot of time here because you guys, everybody already knows about this. There's actually some indicators now. I read an article the other day. There's a few indicators that 25 is coming on a little faster and a little stronger than they thought, and they're already seeing the right magnetism in some of the sunspots, and they think that maybe 25 is going to be an early starter. So hopefully it is. But anyway, there you go. And high numbers of sunspots and high numbers of solar flux. Of course, that's what gives you the best sunspot. So anyway, CMEs and solar flares, just real quick to go through it one more time. CMEs and solar flares, two different things. Sometimes one in the other, they occur together as part of the same cluster, but flares are giant bursts of X-rays of energy, and they come here at the speed of light, okay? And they travel, in all directions, like an omnidirectional antenna or a light bulb. CMEs are clouds of particulates that are hurled into space. This is stellar matter. It travels a lot slower. This is more damaging, and it comes in at a slower rate. Flares only take 8 minutes to get to Earth. When we really don't know ahead of time on a flare. We know one might happen. We know one is, there's a real good chance it's going to happen, but there's no way to know for sure, because even any spacecraft we have that notice it ahead of us still sends the message to us at the speed of light. So there's really no way for us to know. And when I explain this to people, here's what I tell them. The sun could have exploded 5 minutes ago, and the shockwave still won't arrive. We'll have 3 more minutes to show before the shockwave gets here. So you have to look at it that way. This is traveling at the speed of light, and it still takes it up to 8 minutes to get here. Sporadic propagation, something that's going on right now, something that's amazing, something that's really cool. The cause of sporadic is completely unknown, but the most popular theory relates to wind shear up in the higher altitude. It's an amazing thing. It's kind of weird. Like tropospheric ducting is caused by thermal layers. They're saying sporadic E may be caused by wind shear layers. This is some crazy stuff. Anyway, when this occurs, E reflections are almost mirror-like and can result in spectacular DX and QRP, especially on VHF and UHF. Remember, 6 meters is VHF, and it also works on 10 meters. We've had some 10-meter openings, one yesterday, in fact, between here and Europe, between the eastern seaboard and Europe, mostly the Northeast. Monitoring distant NOAA weather stations is a good way to measure its occurrence. If you're ever wondering, go to NOAA Weather Radio in another part of the state on VHF and look at your S meter and write it down. And then on the next day, go there again and look at that same NOAA Weather Radio station. You can use those like VHF beacons, and you can get you can do your own propagation research based on those NOAA Weather Radio stations, because they put out constant wattage 24 hours a day. And it'll give you an idea of what's going on VHF. So I just wanted to put that out there. Find one that's about 80 miles away, 60, depending on your antenna, and use that with your level meter on your radio to give you an hourly or daily or weekly, whatever, idea of how VHF propagation's running. Man. Oh my Lord, we've had some openings. This was 2 days ago. I think I got 76 contacts this afternoon, this 2 afternoons ago, this day. In the Northern Hemisphere, activity peaks from May through early August, when regular sporadic propagation enables long distance contacts spanning up to 1,600 miles for a single hop. Multi-hop sporadic propagation allows intercontinental communication distances of about 6,200 miles, up to 6,200 miles. I've made, I think, 1,500 mile contacts, I think, so far with it. And that's with my 5-element beam. I want you guys to notice in these pictures, and I love following this stuff. You can actually see on these maps, you go to PSK Reporter, and we're going to get into that in a few minutes. You go there and you set it for 6 meters, and you set it for the last 15 minutes, and you tell it to go, and it shows you this map. And I can show you on that map. See how it looks like a big X? The lower part of the map has like an X. There's a cloud right where the X comes together, because people in Texas are talking to people in the Midwest, and people in Florida are talking to the people out in the Dakotas. So that tells me that there's a reflective cloud sitting right over Tennessee and North Carolina right there. Or I'm sorry, I'm too far over. Sitting right over whatever, Kentucky, Tennessee right there. And people are using that. Further north, there's a wonderful reflective cloud sitting right over somewhere in the Midwest there, right along the Mississippi on the north part up there. And everybody that's over along, notice everybody in a long line over there on the West Coast, all able to talk to people in the Midwest. It's amazing. When this opens up, you can see right where the reflective cloud must be in order to facilitate all this communication going in all these different ways. This is science, and it's really cool. I'm telling you what, I sit out here till my wife gets pissed. I can't get enough of this stuff, man. It's awesome. And then I go inside and I dial in on TeamViewer and I sit there and watch movies with her and work FT8 on TeamViewer in the house. And she's like, why do you keep getting up every 15 minutes? And I'm like, I got to move my asthma 22 degrees to the left. She didn't want to hear that. But anyway, anyway, it's a fun time. I got to tell you guys, if you've never done 6 meters during Magic Band season, my God, you can do it with a piece of extension cord, okay, hooked up to your rig that you've already got. It's amazing. Solar minimum. So we're kind of still in this. I know the Mundo minimum was ever last year. I know we're still kind of in it, but what do we do? What do we do? Well, there's a lot of things you can do, and you guys already know most of this stuff, so I'm not going to spend a lot of time on it. But explore other things, try other things, try aurora bouncing and meteor bouncing and all these satellite bouncing, talking to the space station. There's all these other things you can do, VHF, UHF. But the biggest one that I find to be the thing that's great for me is FT8. And the reason is because FT8 allows me to practice with the radio now. It allows me to understand HF now, to understand what band works and how it works, and utilizing Grid Tracker and the PSK reporter and all the information that's available in order to make good decisions on band and azimuth and all these different things. And so I think FT8 is one of the most amazing training tools other than the Baofeng. I think it's one of the most amazing training tools in amateur radio today is FT8. Because when you've made 1,000 contacts on FT8, you know something about high frequency radio. I'm sorry, because you have to understand a lot. You have to figure out a lot. And if you're making 10,000 mile, 8,000 mile contacts over to New Zealand and Australia and things like that, you're doing something right, and it's great. And when you improve your skill and you improve your system, and you improve everything during this time when it's slow using FT8, then when we get back to the phone during the solar flare season, I plan to be back I want to be on the phone. I want to be making phone contacts. So anyway, there's that. FT8, if you're not on FT8, if you've ever taken any advice of anything I've ever said, check it out. If you need help, let me know. I can get some radios on FT8 with a $9 sound card and some soldering and wire. You got to get on anyway. There's some neat services out there. Just want to mention real quick. Vocap. I don't know if has anybody used Vocap? Anybody? I sound like that teacher. Anybody? 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 I haven't used this either. I came across this and it looks really, really cool. So I'm hoping it's all still working and everything. It looks a little complicated, so I didn't dive into it because I had to keep going. You know, when I'm setting up for one of these, it's kind of like the train. It's got to keep going down the tracks. But this looked interesting. So if you've never seen this, you might want to check it out. It's like a program. Well, here, the next screen kind of shows you what it looks like. This is like the screen, and it kind of shows you a little bit of what it does. Pleading ignorance on this. I was kind of hoping somebody out there has used this one, but I'm putting it out there so you can see it and write it down and check it out. If you put in VOACAP, I'm sure it'll come right up. But notice that what I thought was really cool about this, it shows you what bands work in what directions. So like if you're going to be on azimuth 20, it'll tell me, okay, at a certain azimuth or whatever, that this band's not going to really work that well or whatever. And I'm like, that's pretty cool. And there was another, I think this tool here. Oh, I'm not even sure now. This might be the time tool here. Yeah, this is the times here. This is 24 hours a day. And what this is a probability of what times each band would be the best to get on. See, like this is telling you that 21 and 2200 Zulu would be a really good time to get on 20 for us. And I do believe that because that's right about 5 o'clock at night, which is a good time to get on 20. So that's what that's supposed to show you. You can also plot the probability of making contacts and stuff. But like I said, I have not used this thing yet. So I'm pleading total ignorance. The one I have used is called PSK Reporter. Going to go kind of fast here, but if you've never used PSK Reporter, this is probably this and DX Maps. I know some people prefer DX Maps and some people prefer PSK Reporter. That's almost like the Apple and Windows argument. Okay, if you like one or you like the other, or what is it, John? There's the map tracker program that I use, and then there's that other one that you and a lot of other people use. It's a personal preference thing. If you like one or you like the other, stick with it because they're both providing great information. It's the same thing with this, the PSK Reporter, and I'm going to get to the DX Reporter next. The PSK Reporter, what's great about that is it's so quick and easy to use, and you can set it up right on your WSJTX so that you can provide data. It's always important, I think, that if you're going to use data, that you should provide data. It's kind of that human thing. Let's just take a real quick look at PSK Reporter. Up at the top, you choose all bands, or you can select the specific band you want. And they've got all the different bands in there, even the ones that we don't use here, like 4 meters. They're all in there, and you can select different the band that you would like to look at. I like to keep one screen on 6 meters, one screen on 10 meters when I'm doing Magic Band. Show B, you're going to leave this on signals, sent and received. And this explains that if you set that for a specific station coming up, you can tell it whether you want only things that station received or only things that station was trying to transmit to. That's basically what that is. Who, that's where you would put in the call sign if you want. You can put in call sign and you can put in your call sign. I showed this to a couple of people this week, and both of them were just amazed at what this thing will do. Because you can actually put in, and I don't know if I've, let me see if I can go. I've got a few examples here. You can actually, this is 20 meters right now. This is live. There's 20-meter opening right now between the Northeast and Europe. And there's also another one between the Caribbean and in America there. So, or the United States. So, and it looks like South America is able to get into the Northeast as well. So we've definitely got some magic clouds out here somewhere. And then if you want to see, I'm not sure what I've got all pulled up here. This is everything. You can pull this up. This shows you everything. And you can use all the colors are up top here. This is absolutely an amazing tool that I use. Now, if you want to look at what KO4 EFS, this is just what my station has either spoke to or heard from, not necessarily talking to me, but stations that my station was actually able to verify a call sign and a grid for. This is all the stations that my station was able to actually listen to or talk to. So I think this is an amazing tool because let me tell you what I do. Let's say I'm wondering what's going on with 2 meters. Is there anybody on FTA 2 meters on sideband? So you leave it on for 24 hours on another radio over here on an omnidirectional antenna. You stick it on here, you turn on the PSK Reporter, you turn off the screen, you forget about it. You come back 24 hours later, you go to this, and you can pull up your PSK data from your machine for the last 24 hours and see if it ever did hear from any of those stations out there. So that's really a cool thing. So there's just a lot of different things that you can do with this. It's just absolutely an amazing thing is the PSK Reporter. Now, real quick, a couple of things you want to do when you get in there is you want to go to your settings screen, and you get to this screen by clicking display options up here. Okay. And real quick, your mode and your hours, that's all self-explanatory. I don't need to explain that to you guys. Display options, you click that. When you click that, you end up with this screen. One of the things you might want to do, I click these just to keep the clutter down. And I like the connecting lines. So I click show connecting lines. Other than that, I pretty much leave it the way it is. You can change this here. Look, you can change this here. One map has like a globe. The other map is the one that's stretched out like this. So you can have it however you want it. There's a lot of really cool things you can do here. One thing you want to change is distance to miles. It comes in kilograms or whatever. And put that connecting lines there. All right. Those are the main things. On your WSJTX, be kind and be a data provider, please. It relies on all of us to do this. You just go to your reporting tab, click that box, and then click OK. That's all you have to do. But if you don't do that, you're not helping us out. Okay? That's all there is to it. So if you're on FT8, please take a quick look at this for me. Go to your reporting tab, turn on the PSK reporter. I don't think Al-Qaeda is going to use it to find us or anything. Turn on your PSK reporter, click OK, and you're all set to go. All right, DX Maps, another really, really good program that I'm not going to take time to show you. It actually probably does even more than PSK Reporter and is an amazing resource. And I love the maps, the way this thing produces the maps. It's got some amazing functions up here, but you're going to learn it yourself. I don't have time to teach you tonight. But definitely, if you like PSK Reporter, go check out DX Maps and vice versa. How much does the antenna matter? You know, it's not just what kind of antenna you're using, but there's one more thing I want to talk real quick about, and that's takeoff angle. This is something I didn't realize till later on a little bit. Your NVIS, your near vertical instant skywave. I'm so surprised I'm able to come up with all this. I love that because the takeoff angle is really high and you get closer stations. You can do DXing and stuff with it. Really cool. But their takeoff angle is important. If you're using an inverted V, changing the inversion of your V can actually affect your takeoff angle some. So there's different things you can do for that. And so I suggest that if you've looked at everything else and you want to try something different, look up how to take whatever antenna you have and see if there's any way to adjust the takeoff angle a little bit. Go up or down on the takeoff angle. The gray line. This is something I find really cool. You could actually talk across the gray line. Like you're in, let's say, the nighttime, but yet say the place you're talking to is in the daytime. So you're actually talking from one type of atmosphere into another. And you're thinking, well, that makes it worse. No, a lot of times it actually makes it better. You can actually go DX further is if you're crossing a gray line. The way it works basically is all the layers don't change at the same time. The D layer disappears, allowing HF signals to better get to other layers. So right before dark, as the D layer is starting to disappear, you're actually going to get some of the nighttime benefits, even though it's still kind of daytime outside. So that's one reason why working that helps. E dissipates a little later, and then the F1 and F2 remain. And then eventually the F layers will combine, because at night you just basically have one big F layer up there at night. So while all these transitions are happening, you can take advantage of using that opportunity to bounce signals off of things. And it changes the actual gray line, changes the propagation characteristics from your station to the one you're calling, if one is in day and one is in night. That's really cool. I say that's really cool after every slide. I apologize for that. Okay, VHF and UHF propagation. This is really cool. This doesn't have a whole lot. It all has to do with the sun, but this doesn't directly have as much to do with the sun as it does basically a thermal layer in the lower atmosphere. This happens much lower in the atmosphere. I noticed this a lot with our FM radio station. If I start getting calls and people say, all I hear is Spanish music, did the federal government finally shut you guys down? I said, no, they didn't. It's called tropospheric ducting. And what it does is it actually creates a trough in the upper atmosphere, and the radio waves are actually ducted down, and it creates a situation. Usually by then they hang up. But anyway, it is really a cool phenomenon, and it affects our stuff too. It affects 6 meter, it affects VHF, and it can affect UHF when it's running really bad. What basically happens is just kind of what I just said. There's a thermal layer that sets up in the atmosphere, and it takes FM signals, mostly FM. VHF is most susceptible to it, between 50 and 150 megahertz. And it basically creates like a tunnel through the atmosphere at a low level, and it drops that radio signal back down on the other side. And so what ends up happening is the radio station that sits out on St. Petersburg, that's propagating over nothing but water, thank you very much, it actually comes crashing down on top of our signal that's trying to fight up over Fort Myers coming from a stereo. Okay. And so what ends up happening is it pushes back our signal, and people wake up in the morning, they hear Spanish music, their alarm goes off, they want to hear their news and talk, and they end up hearing Spanish music, and they immediately think that it's the end of the world. And it's not. It's tropospheric ducting. It's an amazing phenomenon when it happens. And we find out when this happens that people down in Alamorada are listening to our radio station in a stereo, because when it happens to us, it ends up pushing the Key West station further down. So it ends up moving everything down. So that's tropospheric ducting. So if you're ever sitting there one day on the 685 and you hear the Bradenton repeater loud and clear, I did that one morning. I was sitting here listening to them guys checking in up there, and it was loud and clear. So I went and programmed in that PL and checked in on their net. The ducting was working great, and it normally works in both directions. To find out about tropospheric ducting in real time, you can go to the Southwest Florida TechNet website. Under the Propagation tab, click tropospheric ducting. Detrimental sunspot activity. Sunspot activity can be detrimental to radios, satellites, GPS, our astronauts, and even our power grid if a strong enough EMP pulse was kicked off. See, we've been talking about all the cool stuff up till now, but it gets a little darker going forward. These basically this energy that's basically unleashed at us from the sun, it causes these beautiful auroras. That's great, but it also creates all those kinds of solar flares as well. And we're going to be talking about all that in just a minute. But before we do, I want to get into some tips and tricks. This is some real neat stuff I picked up along the way when I was doing my research. If you're in a QSO, when a major flare causes an HF blackout, it seldom lasts more than an hour. Like I said, that one I witnessed lasted about 22 minutes total was the total blackout time. If you're working a contest, this could be useful. Take a break. The X-rays do provide extra ionization in the ENF layers, and they do improve reflectivity and a higher muff. So exploit the benefits of a solar flare. Either they might increase your contesting, and that's great. They might shut you down for a little while. Take a break. Good DX contacts are possible immediately following a solar flare until sundown, due to the improved reflectivity and better signal to noise ratio for QRP signals, and the higher muff opening in higher bands, especially during the solar minimum. So basically what that means is, let's say it's 4 in the afternoon and a big solar flare happens on the sun. Between 4 and 7 o'clock, between the time things open back up and 7 o'clock when the sun goes down, you could see unusually high propagation on day bands, like 20 meters, because of the way this sets up, and the noise floor is going to be really low. Most important thing to remember about a solar flare is this. The HF effects are generally only for the duration of the flare event, 20 to 60 minutes. And They seldom affect frequencies below 10 megahertz. So basically, 40 and 80 aren't really that much affected by solar flares. They're affected by other things, but not solar flares. Use the current K index from the WWV or the internet to determine the current geomagnetic field conditions. The A index is actually yesterday's geomagnetic field condition. And that's, like I said, that's if you're getting more into the advanced stuff. QRP propagation. Often our magnetic field gets very quiet following a strong geomagnetic storm for 12 to 24 hours. This is an excellent time to work 40 to 160 meters due to the noise level being very low. So once again, following a major solar storm, we're going to see unusually low noise floors. And it's a good time to get on. The solar flux indicating the level of ionization. That's that farthest left number up there that I told you to watch out for. We're looking for values 90 and above. The solar flux indicating the level of ionization affects HF propagation above 10 megahertz. The solar flux does not affect 40 megahertz and below, since the muff seldom drops below 10 megahertz. This is why the lower bands are always open. And yeah, you'll find it doesn't, again, it doesn't have as much effect. 20 is highly susceptible to radio blackout. Okay. 30 meters is the ham band caught between two worlds. It can be affected by both solar flux and the K index. On the other hand, it is more often not bothered by either one. It's a good band through the solar cycle. So again, if one's screwy, the other's screwy, the one in the middle might be the magic one. You know, you never know. Every solar flare and the resulting storm is different. No two are alike, and they cannot be accurately predicted. We can have one that is almost a near miss, and we know it's coming right at us, but until it actually arrives, we don't know how much of that energy our shield's going to have to endure. Never let reports of flares or geomagnetic storms or the lack of scare you from getting on the air or checking it out. I have gone on in almost every imaginable condition during this quiet, and I've always found some band that I can find somebody on. So don't ever look at a solar flux index or look at the band openings in Europe or look at something like that and decide, you know what? Not going out to the shack tonight. I'm going to bake cookies instead. Don't do that. I'm telling you, go to the shack, because you never know what's going to be on the bands. It doesn't matter what that stupid thing says. The Carrington event. I don't know if you guys have heard the Carrington event, but it was a big event. It happened on September 1st and 2nd in 1859. It was during solar cycle 10. I was pretty young, so I don't remember it that much, but apparently it was pretty bad. During the Carrington event, basically what happened was the Earth was almost directly in line with a coronal mass ejection, basically. And it was observed by an astronomer named Carrington, and that's where we get the name. And basically what happened was, all of a sudden, he sees this thing, and then later on, a bunch of stuff starts happening. But this energy comes in, and as it comes in and it wraps around our shield, and it gives it quite a bit of hell. Anyway, I'm not going to go through this whole thing, but basically what we got here is the perfect superstorm in 1859, the Carrington event. That actually is a drawing that was done based on the observations that were made through solar telescopes at the time. Obviously, there's no photography or anything else other than just the written word that people put down, and this drawing that was made by Carrington and some others. On the morning of September 1st, amateur astronomer Richard Carrington ascended into the private observatory attached to his county estate outside of London. After cranking open the dome's shutter to reveal the clear blue sky, he pointed his brass telescope towards the sun and began to sketch a cluster of enormous dark spots that freckled its surface. Suddenly, Carrington spotted what he described was two patches of intensely bright white light erupting from the sunspots. 5 minutes later, fireballs vanished, but within hours, their impact would start to be felt across the globe. That night, after this, after the event happened, when all this energy began to arrive here at the planet, telegraph communications around the world began to fail. There was reports of sparks showering from telegraph machines, shocking operators and setting papers ablaze. They actually unplugged their batteries, and they were still able to send messages vast distances just from the electricity that was being collected by the lines. They could unplug their batteries and transmit at 30 to 90-second intervals. Some thought it was the end of the world was at hand. A massive solar flare with the energy of 10 billion atomic bombs spewed electrified gas and subatomic particles towards Earth. The resulting geomagnetic storm, dubbed the Carrington event, was the largest on record to have struck the planet. Americans in the South were particularly startled by the northern lights, which migrated so close to the equator that they were seen in Cuba and Jamaica. Can you imagine waking up in Southwest Florida to green and red auroras dancing in the sky? I would hope that my antennas were unplugged. In Abbeville, South Carolina, masons awoke and began to lay bricks. They thought it was time to get up. The sky was so bright, they thought it was morning. In cities across America, people stood in the streets and gazed up into the heavens at the pyrotechnics. In Boston, some even caught up on their reading, taking advantage of the celestial fire to purse the local newspaper. Newspapers from France to Australia featured glowing descriptions of brilliant auroras that had turned the night into day. And they did some ice core samples. This was the biggest event like this in 500 years. This is the big one. What would happen if this happened today? I mean, think about it on this scale. I mean, that's some amazing stuff. Well, okay, we'll start here. All of our stuff right now is hardened, okay? You know what hardened means? It means it takes more abuse before it goes down. That's basically all it means. Satellites. Our satellites can go down temporarily or permanently. If it affects their flight systems, they'll eventually all just burn up in the atmosphere and come back that way. It could just burn them out and they'll just float around for a while before they slowly come back. If all of them go out, we know where we're at. I don't need to tell you. Power grid. The big thing during a solar storm like this is the power companies are literally going to have to dial it back to zero. They're going to have to bring the power down to nothing, because the power that our power lines were going to, all of our power lines are going to be like a collector, and they're going to collect all of this electromagnetic energy, and they're going to try it, and they're going to try to move it across the electric grid like electricity. And it's going to overload everything, the equipment that moves it, the equipment that's plugged into it. So power grid, definitely not just the grid, but anything plugged into the grid is at high risk. Connected equipment, anything connected. Radios, again, your antenna is an electromagnetic collector, and it's up there collecting. So you can do the math. If the storm's big enough, it would affect your radio and damage it. Computer chips. There's fine hairs inside of every one of these little chips. There's little teeny microscopic hairs in there. And if those hairs are exposed to enough of this electromagnetic pulse that comes in, they fuse. And once that happens, that piece of equipment is 100% useless going forward. It will never be revived. And the data that's on it is lost. Communication systems, connected systems, like cell phone systems are incredibly vulnerable to stuff like this. Of course, some of the systems we use are more hardened, a lot, because we're there to unplug them and protect them. Part of our hardening is not that we've spent millions of dollars like the government to harden something. Part of it, when we harden something, is I know when to unplug the damn thing so it's not going to get blown up. If you have spare equipment, keep it disconnected. Now, I'm talking about, this could be for any reason, okay? One thing that another country might do as warfare is touch off an electromagnetic pulse over us. And that would have a very similar effect to a solar storm. So when I'm talking about this, what I'm about to talk about applies to both energy from the sun and also a man-made electromagnetic pulse device. Either one would apply, okay? If you think either one of these may be possible, if there's a huge solar flare, a huge, not a sunspot rotating around, and it's the nastiest one in 50 years, and just unplug everything. Unplug everything. Make sure that the shell of your shack is grounded, and just unplug everything. Have nothing plugged into antennas or power or ground. When your radio is completely unplugged, unplug the ground from it too. Unplug everything from it and isolate it inside a metal box or a metal garbage can. Keep equipment turned off. Keep antenna power lines disconnected. Connect only the external conductors necessary for the current mode of operation. So in other words, if we're thinking there might be a bad solar storm and it could happen, this is something that may not happen for years, guys, but it's something that potentially could happen. If we think something like this may happen, it's probably a good idea. Take your primary 2 or 3 radios and sit them down inside a metal garbage can and put it over to the side and hook up your backup equipment and utilize your backup equipment to get through it. You want to keep, you want to save something. Okay. Tie all fixed equipment to a single point earth ground to prevent closed loops. This is if you're leaving it set up. Keep everything grounded if you're leaving it set up. Obtain schematic diagrams of your equipment, tools, components, repair of equipment. This is where a lot of people are, there's always that argument. Well, I've got all my manuals for all my radios and all my programming guides and all my frequency lists and all my ARRL disaster guide and my Aries guide, and everything is all on this thumb drive. I don't know, guys. Is that enough? You're going to have to plug that in somewhere to look at it. So there's something to be said. I don't know if I've got it here somewhere here. I've actually got a 3-ring binder that I've got the Aries guide in, and I've got all of our frequency lists and all that. And I'm actually starting a paper one. I've decided to go old school on some of it just in case it gets really bad. So you might want to have really critical things on paper. Have spare parts on hand, sensitive components, radio equipment, antenna systems. Never hurts to have spare stuff. Know how to repair and replace sensitive components on your own radios, and use non-metallic guidelines and antenna structural parts whenever possible. Obtain emergency power source. Of course, it's always best to do that. Anytime you're connected to commercial power, that is going to be your biggest threat for electromagnetic pulses coming into your shack, more than even your own antennas. Equipment power cords should be disconnected when gear is idle. Again, if you're not using it during a threat, I leave all my stuff on all time. But if there's a threat, I'm going to protect some of it. I got to keep some of it back. Have a spare antenna and transmission lines. Believe it or not, a bad enough solar storm is going to damage your coax. So that's something to keep in mind. If coax is not connected, it will not be damaged. So if you've got backup radios connected and we get a bad pulse, it could literally affect your coax line. It not only destroy your radio, but your antenna and your coax line could also be at some kind of threat as well. And here's something that a couple of you guys are really going to like, Dave, and a few of you guys. Keep some of that tube equipment around, man. Keep some of that stuff around that doesn't need computer chips to talk. And don't rely on anything that, have a way to do everything without a microprocessor, basically. The Faraday cage, I don't need to tell you guys about these. I'm just going to gloss this, but Faraday cages are important. You can make a Faraday cage out of anything. They sell those little metal bags now that you can put stuff down in. They're big enough to put like a mobile radio down in. You can put them in like a Ziploc, aluminum Ziploc Faraday bag, I think they call it. Metal garbage cans. I keep coming back to that. I'm going to buy me a metal garbage can, and I'm going to put it in the shack, and it's going to be part of my shack right here. And any radio that I don't have hooked up for use, I'm just going to sit down in that garbage can and put the lid back on it. Why not, right? If I'm not using it, why let it sit on the counter? I'm going to put it down in the garbage can where it's safe. As long as my wife doesn't come in and throw that garbage can out. Here's some other things you might want to consider saving. Calculators. Yeah. Anything with electronic ignition, it could be damaged. Cars, or for instance, that's something people take for granted. During a huge EMP, your car will not start. Cars made before the 80s will. So that's where, it all depends on how electronic your car was. All right, let's go through some web resources. I just got a couple more I want to tell you guys about. We've got spaceweather.com. This is my favorite website. Absolute favorite website. I go here every morning and I check this before I check my news sources or anything else. I love spaceweather.com. There's always what's going on right now is the first thing you see, and the second thing is an article about something else that's going on right now. So those are great. You're going to see things on here about your meteor showers, about any CMEs, any solar storms, anything. It's all going to be reported on here. You're going to get advanced notice of things on here. It's really cool. So spaceweather.com would be my number one go-to.